All right, everybody, this is a review for Lab 7 on one-way ANOVAs. So we're going to use SPSS to calculate a one-way ANOVA. And after learning how to calculate these by hand, you might come to appreciate how quickly SPSS can do this for us. So that's what we're going to do. We're going to compare three groups. Remember, an ANOVA needs at least three groups. So we'll be looking at three groups from three different majors. We're going to be doing a comparison across college, major, and IQ scores. So remember, an ANOVA relies on our variables behaving in a certain way. We need a categorical variable or a grouping variable. Then we need a dependent variable that is on a sort of scale, a ratio variable. So that's what we're working with here. We'll have groups by major, and then we will have IQ scores as our continuous or scale or ratio variable. So as we normally do here in SPSS, we're going to start by, and I have it open in VMware here, we're going to start by going into variable view and creating some variables. So we're going to have a variable for the group or major. You could call this major if you wanted. So for the group in IQ, I've actually included some labels here. These labels, I'm not sure if we've used these before so far, but this is actually going to label our output a little bit more clearly, so you can have names for your data set that are a little more concise than these labels here. But so we have that, and then we need to assign measures to these here. So our grouping variable is going to be nominal or categorical, and IQ is on a scale. So remember that with nominal or categorical variables, it's often in our best interest to code for our different values here. So why don't we go ahead and do just that? All right, we need to create three codes for our three different majors, right? We're going to have English students, math students, and psychology students. So we've done this before. If we hop into values here, we just want to give each of these a different value. All right, so 0 for English student, 1 for math students. All right, and 2 for psychology students. All right, okay. So now we're ready to put in some data in data view. So let me make one thing clear here. This image right here, this image on the PDF instructions of our lab here, this is a screenshot from Excel, okay? So SPSS does not look like this. SPSS, of course, looks like this. So we're gonna put the data in this way. So SPSS receives data in a different way. It receives it in codes, right, or grouped variables. So since we have our group set up here, instead of having three columns for each of these groups, what we have instead are codes. So we have 15 data points for each of these groups, 15 students in each of these groups. So we want 15 of each of our codes, all right? So that's our 15 English students. Then we'll have our 15, oh, a little too far, 15 math students, and then we will have our 15 psychology students, all right? So we have this entire column here devoted to our codes, and then we would go ahead and put the data in this way. So if I start with English students, we have a 44, a 40, a 44. I'm just moving down the list this way. So you would do that all the way through the zeros, and then for the ones, you would do the same. So I'm starting with 36, 40, 37, right? Taking these here, since these are the math. These are math people, right? And we would do the same for our last group, for psychology, all right? So 52, 50, 51, all right? So now we have data in here, and of course you will have all the data, as I often do with these kind of overviews of the lab here. You will put in all of the data. It will look like this, but you will have 45 rows, 15 data points for each of your coded group, so for each of our three majors. And then we're set up to run an ANOVA, all right? We're set up to run an ANOVA, so we're going to go ahead and do that. We're going to do a compare means and a one-way ANOVA. So we're going to analyze, compare means, go to one-way ANOVA. So it'll want us to make a few selections here. All right, so the main ones being, let's give a little more room here. The main ones being that we want to move our group to our factor And we want to move IQ to our dependent list. Remember, IQ is our dependent variable. But we also want to go into options and grab a few more things here. We want to get descriptive statistics, so that'll be things like mean, standard deviation. Of course, we know what descriptive statistics are now, right? So that's what we want, and then we'll go ahead and run this, and we'll see what it gives us in our output. So remember, my output is going to show an n of 3 for each group, but you are going to have more than that because you'll have 15 in each group. So you'll want to check to make sure that that's what is showing in your output. So let me go ahead and make this a little bit bigger here. So we have our 3 groups, all right, and our total, your total will be 45. We have means for each group, standard deviations for each group, and then of course a smattering of other descriptive statistics, including confidence intervals, which we also learned this week. And then you'll have an ANOVA table. The ANOVA table will tell you if the ANOVA is significant. So some of this should look familiar, all right? We have sum of squares, between, within, and total. All right, those are the components, remember, to calculating an ANOVA, as well as degrees of freedom. Mean squares are calculated here as well. Then ultimately an F value. All right, we have an F value, and we look here to our significance value. Remember, our significance level is usually set to 0.05 or 0.01, and this is most certainly below that. So it seems we have a significant difference here. But again, this is for my smaller set of data, but that's how we would generally read this table here, all right? So you should have one that looks a little more like this, all right? That includes all of the data. So if the ANOVA is significant, which hint, hint, you know, it is, I'll whisper that to you. But the ANOVA is significant. We figure that out by looking at the significance column. If the p is less than 0.05, it is significant. So as we learned previously with ANOVAs, we're kind of limited when we run an initial ANOVA. If we find a significant difference, it's just stating that there is a difference somewhere among our groups, but it doesn't tell us specifically what that difference is. So we want to hop back to the data set, and we'll go back to compare means. Let's go back to analyze, compare means. Well, too far. Compare means, one-way ANOVA, and we're going to click something else this time. We're going to click into post hoc, and we're going to click into options. All right, so let's go into options, and let's select one thing here. Let's select a means plot. All right, a means plot. This will be interesting to look at. Then when we go into our post hoc categories here, we're selecting something called a Tukey test. All right, sounds like turkey without the R. Okay, a Tukey test. A post hoc analysis is analysis done after the initial analysis. All right, so post hoc would be after you immediately address your hypothesis, and then we move onward from there. So we're going to select, if we move back over here, all right, the Tukey test, and we want the significance level at 0.05. You could, of course, change this to be more conservative if you wanted. Let's press OK, and let's see what we get. It's taking its time. It's making me a plot. Okay, look at this means plot. This is, let's see if I can get this a little bigger for us to see here. We have a means plot, which is showing us visually the difference in all of our means. All right, so we have English, math, and psychology students. We can see the difference in IQ scores here, mean IQ score. And let's see what else it gave us. All right, all right. So it ran the ANOVA here. Now we have our post hoc test. So our post hoc test gives us some more significance values. So what this is doing is a multiple comparisons test, in which it's comparing each of our groups to each other. So if we take a look at this table, we have a comparison for English students to math students, and if we scoot over to the significance level, we can see that there's a significant difference between the two. If we go to English and psychology, we can see a significant difference between the two. So notice that all of mine are significant. Not necessarily all of yours will be significant, because remember, I don't have all the data here. But that's how we would read a table like this. So that's how we determine differences on the individual level. So remember, this is not something that we have learned to do by hand, to calculate by hand, because it's a bit tedious, right? We'll leave it to the computer. So there's some more details here about how you would read a plot like this So go ahead and just take a look and see what you think. I have some questions here. You don't need to actually answer and submit these, but just to think about how we would read such table. And then, as with many of our labs, you are submitting the output or the SPV file or this file. All right, so I should see your means plot, your Tukey test, and your ANOVA table here. So that concludes this lab. Please be in touch if you have any questions.